Hello friends, welcome back. So in today's session we will see typecasting. So let's get started with that one. So what is typecasting? A typecasting is nothing but a process to convert the data types. We have already seen what is data types. The data type is nothing but a storage that will define what type of data that we want to store. So we have to do the typecasting for that one. So typecasting, we can say that it is a process to convert the data from one type to another type. Typecasting can be done for primitive and non-primitive data type. We have seen the types of data types also, primitive data type and non-primitive data type. Primitive data types, 8-9 types are there, that is int, float, double, boolean, short, byte, character. So these are the primitive data types. If we want to do the typecasting for primitive data type, then we have to use, then that also we can do, or for reference type of data type we also can do typecasting. So this is called typecasting, a process. Typecasting is a process to convert the data type from one type to another type. And typecasting has two types. One is implicit typecasting, another one is explicit typecasting. Implicit typecasting your compiler will do. You don't need to do implicit casting. Automatically it will happen by the compiler. And explicit typecasting programmer has to do. Without that one your compiler will give error. So you have to do programmatically. So that is, implicit typecasting is done by your compiler and that happens automatically. But explicit typecasting programmer has to do through the code. Okay, and here is a syntax. Here is a syntax to do typecasting. So this is a destination type. Destination type is nothing but the type only, in which type we want to typecast. That is a destination type. And source type is what type that we want to typecast. Variable name, in which variable we want to hold the value. And destination type means what type actually we are making the typecast. So this is the syntax for typecasting. Suppose here we are taking one example, typecasting for primitive data type. So here one example is there for implicit typecasting. We are doing the typecasting for primitive data type. So in primitive data type, how we can do implicit typecasting? As we have already seen, implicit typecasting is done automatically by compiler, but we have to understand the concept once. Suppose we have declared one variable byte x with value 120. We know 120 value 120 is within the range of byte. Byte range is 127 minus 128 to plus 127, that is the range of byte. So within that any number is there, that number you can assign to byte variable. So this byte x is a type of byte, means we are acquiring memory of 8-bit. Byte is nothing but 8-bit only. So your compiler, at the time of JVM will acquire 8-bit of memory, and inside that memory 120 value your JVM will add. Your JVM will store value 120 inside variable x, and x is a type of byte only. So JVM will acquire 8-bit of memory with variable name x, and inside that variable memory allocation your JVM will store 120 value. And after that one we are doing typecasting. So this is implicit typecasting, because you can do explicitly, also. Implicit typecasting you can do explicitly also, but not required, your compiler will automatically do. So this is implicit typecasting. Why? Because X is a type of byte and Y is type of int, and we know int has a more bits to store the value. Byte has 8 bit and int has 32 bit. It means for int memory location is more than byte. So in that case, whatever the value is there inside byte variable, you can typecast or you can store into int variable, no issue, because int has a more memory, and byte has a short memory. Byte has 8 bit only, but int has 32 bits. So 120 can be stored into variable Y very easily without any harm. Means the process of converting lower type to higher type is called widening. Widening means you are, suppose one object you are taking from short memory and that object you are storing into wide memory. So that is widening, and widening is always safe. Why it is safe? Because 120 that is holded by a byte variable that can easily store into int variable, because int has a more memory. So that's why it is a safe. So here we have taken one example. Suppose 120, when we declare byte X as 120, your JVM will acquire 8 bit of memory. This is 8 bit, 1 2 3 4 5 6 7 and 8, and 0 1 1 1 1 0 0 0. This is a binary number, that means 120 only. This is a binary number. Because internally your JVM will use binary numbers only to store the data. So this is a byte this is a binary number that representing 120, and inside memory it will store in 7 bits only, because 8 bits is 0, because from this this is 1 2 3 4 5 6 and 7. Only 7 bit is required to store 120. Even 8 bits is also not required, but byte has a minimum 8 bits you have to acquire, because one byte at least you have to acquire. So inside that 120 value you can easily store. So, and if you store that into int, then your JVM will acquire 32 bit memory, like that. This is 32 bit. Inside the 32 bit, the first 7 bit you can easily store as it is. Remaining bit will be 0, because you have to store 120 only. So this first 7 bit is enough to store, and remaining bit will be unused. That will be zeros. So this is also 120 and this is also 120, and if we print the value of X and Y, then also that will be 20 only. So this is called implicit typecasting for primitive data type. And for explicit typecasting, if you say, so this is explicit typecasting. Here we have declared one variable int, integer type variable. Now you see clearly, integer type variable X we have declared, and we have assigned value into that X variable is 310. So X is holding 310 value, 310, and that we are typecasting. So this is explicit typecasting. In compiler will not do. If you directly assign byte Y is equal to X like that, byte Y is equal to X, and you remove this typecast statement, in that case your compiler will give error. What error your compiler will give? Your compiler will give cannot typecast to higher type to lower type. lower type, and this is called narrowing. Narrowing means is the process of converting higher type to lower type. Int is higher type than byte. Int is higher type than byte. In that case, if you are doing typecast, then that is called narrowing. Narrowing means the process of converting higher type to a lower type, and that is unsafe. Sometime it is unsafe. Suppose inside X, if you are storing 120, like that only 120, then that is a fine. Then also 120 can come into byte. But this is a 310. 310 is out of the range, out of the max range of byte, because max range of byte is 1 to 7 plus 1 to 8, minus 1 to 8 to plus 127. This is the max range of byte, but the value actually your integer variable is holding, that is 310. So that is more than that. In that case, you may lose some data. How? Because to represent X, to represent 310 into memory, you need 9 bits. Yeah, 9 bit is required to store this value. So what you will do in that case, if you are doing the typecast, then your JVM will store the 8 bit only, first 8 bit only, and it will skip the remaining bits. So that's why it is unsafe conversion. You may lose data. It is not like that you will lose every time, but chances are there you may lose the data. Suppose if the value is within this suppose if the value that is holded by X, that is within the range of byte, suppose 100, 50, 50, 120, 90, 98, like that. So in that case, byte can also take that value. So you will not lose any data, but chances are there, because in the higher type you have stored the large number that is exceeding the length, then the length of byte. In that case, there is unsafe. You may lose some bits. Suppose here we have taken this example only. 310, to store the value 310, we need 9 bits. See, this 9 bit is required to store 310. This number is of 310. This number is 310. But if we want to store that number in byte, then byte can store first 8 bit only. The remaining bits it will skip. It will skip that remaining bits. Only the first 8 bit in byte can be stored. So in that case, this number will be something different. Some 54 or something this number is. In that case, you have lost your data. You have stored 310, but after conversion you are getting 54 or something. In that case, this is unsafe conversion, because you may lose some data. And this is called explicit typecasting, because explicitly what we have to do, explicitly typecasting, if we directly do, then we will get compilation error. Your compiler will not allow to do that one, but still if you want, you can do. So you will lose some data. So let's see through the code also. Suppose inside int we have declared 310 here. 310, this is in integer. In integer we are storing 310, and the 310 is not within the range of byte B. Or if you want to take this upside, you can take that also. According to that example, we can take, no issue. Yeah, first one is explicit. Implicit typecasting. So in implicit typecasting, this is implicit. Implicit means implicit means done automatically. So this is implicit typecasting. This is implicit typecasting, this is explicit typecasting. Okay, so first one is implicit typecasting. So if we see this is the example of implicit typecasting. Implicit is what automatically your compiler will do. So this is implicit typecasting, and this we have taken this example. So here inside this x we are storing 120. Inside this x variable we are storing 120, and x is a type of byte only. It means only the 8 bit, only this 8 bit is acquiring your JVM, and inside that one your JVM is storing 120, and 120 value is this one 000111110. First 7 bit is required only, first 7 bits is required only. So your JVM is storing inside this byte variable x 120, and that value if you want to store into integer, that you can do, because integer has a more memory than byte. So your JVM, definitely your JVM will store your data safely as it is, without any harm, or without without losing any bits. Your JVM will store this one, and it will do typecasting from byte to int. So this is implicit typecasting. So here if we are printing value of x and y, value of x will be 20 and value of y will be 20. Both will be 20, because byte has a less bit than int, and inside byte whatever we are stored, that can be stored into int, no issue. So this is a safe typecasting, and this is also called widening. And this is explicit typecasting. Explicitly means here we have stored inside int variable a 310, and 310 you can store into integer, because integer has 32 bits. 32 bits are there for integer, so you can store 310. But what if I want to typecast to byte, because byte has 8 bits only. So whatever the first 8 bit, these are the first 8 bit, whatever the first 8 bit, that will come into byte, and the remaining bits will be skipped, that will become lost, and the first 8 bit only your JVM will store into B, whatever the first 8 bit of A. So this will, here A and B value will be different, but x and y value will be same, because from byte you are typecasting to int, and because int has a more memory than byte, then definitely the exact value you will get. All bits safely you can store, your JVM will store. But here you are going from int to byte, in that case some bit you may lose. If it is exceeding, if value is exceeding, then the range of byte, and definitely this value is exceeding then the range of byte, in that case value of A will be different, but value of x and y will be same. So let's see the output. See, x and y is 120 only, x and y is 120 only, but value of A and B is different. A is a 310, but B is 54 only, because your JVM has took the first 8 bit only, and this first 8 bit number is represented as 54 only. This number is 54 only. This number is 310, but this number is 54 only. So in that case this is called narrowing. This is narrowing, this is widening, this is safe, this is unsafe. This, okay. So the next is, this typecast we did for primitive data type. Next one we will do the typecasting for non-primitive data type. So to do the typecasting for non-primitive or reference data type, one condition is there. What is that? The type should be in inheritance relationship, like that. Type should be in inheritance relationship. to do the typecasting for reference type, inheritance relationship should be there between objects. Yeah. So if this condition is satisfying, then we can do the typecasting for reference variable. Suppose from this diagram what we can understand here, A, B, C, D, E, these are the types, these are the classes. A is extended by B. Oh, extended means inherited. A is inherited by B, B is inherited by C, and C is inherited by D, and D is inherited by E. Or we can say that B is inheriting A, C is inheriting B, D is inheriting C, and E is inheriting D. Or we can say E is inheriting D, D inheriting C, C inheriting B, or B inheriting A. So inheritance relationship is there. Now we will do the typecasting. Suppose this is one example, first example. Implicit typecasting I am doing. Implicit typecasting. What is implicit typecasting? Implicit typecasting means done automatically by compiler. So here we have declared a variable D, type D, and object is also a type of D. This is object. We have seen how we can create the object, everything we have seen. This is object of D, and we are storing inside the reference variable of D only. Inside the reference variable D we are storing object of D, and that we can store into A. How? Because whatever feature is there in D, whatever the feature is there in A, D all that feature have. That is the meaning of inheritance only. One object is already there, we are acquiring the properties and the feature of that object, and we are adding some extra feature in that one. That is the inheritance only. So we can say that whatever feature is there for A, whatever features are there in A object, all features are there in D, and along with that some extra feature are there. So what? No harm. Your compiler can do, because this object is D type, and that object you can typecast to A. You can directly store without any typecast statement, because this is implicit typecasting. Your compiler will do by itself only. Your compiler know D is also type of A. Object D is also type of object A also, because D is inheriting A. So this is implicit typecasting. This is also called upcasting. How? Upcasting means how object is a type of D, but that we are typecasting to A. We are typecasting to upper level. From this diagram we can see A is upper than D. We can see like that. A is upper than D. So this means from D we are going to A. Means from object D we are typecasting to object A. So we are doing upcasting here. So this is also called upcasting. So yeah, this is implicit typecasting example. Another one is explicit typecasting example. What is this has to be removed, actually by mistake we added. Okay, leave this. So explicit typecasting is what? Explicit means we have to do typecasting explicitly. Suppose inside variable A, this is variable A type reference A. In that one we are storing the object of D, and that A is also type of C, but you have to tell to your compiler, please typecast to this type only, because this is a subtype. In subtype, if you are doing downcasting, in that case you need typecast, means you need explicit typecasting. if it is a downcasting. How it is downcasting? Object D you are storing into the reference of object A. Same thing we are doing. Object D we are storing into the reference of object A. Later on I want to typecast to C. It means from A we are typecasting to C. We can say like that. Object reference is A type. From that one we are doing downcasting. For downcasting we need explicit typecasting. This is explicit typecasting. This is also called downcasting. Sometimes we will get exception also, because if we have taken same example, reference of type A, inside that one object of D we are storing. We have stored the object D inside reference of object A, but what we are doing here, we are typecasting to type E, but object E itself is not there. We have not created any object that is type of E. Object inside reference variable A, object is type of D only, not E. We have created object of D only. Then how we can typecast to E? Because see, whatever feature is there in A, all feature are there in D. Whatever feature is there in A, all feature are there in D. But whatever feature is there in E, D don't have that feature. Why? Because D is not the subtype of E. Whatever feature is there D, all feature E has, but whatever feature is there in E, D don't have all the features. In that case, object is type of D only, but you are trying to typecast to E type, means subtype, but object is one upper type. Then you cannot do typecast at all. Then what your JVM will throw? It will throw class cast exception will be thrown. Because why? Because object A, what is the object A? Object of type D. Inside reference variable A, object is type of D only. So it is telling class cast exception will be thrown because object of A is not type of E. Yes, object of whatever the object reference holded by variable A is not a type of E, so you cannot do the typecasting to E. So it will give the class cast exception. So this is a one problem here. See, this is a one problem. Okay, first we will see this one. So here, see, if I show you the code A, this is class A, this is class B, this is class C, this is class D, this is class E. So if you see, inside class A we have declared one method A. Class name is A, so I given method A. That's it, to differentiate. So inside class A, method A is there. Inside class B, method B is there. Inside class C, method C is there. Inside class D, method D is there, and inside class E, method E is there. But if I repeat this one, then what you will observe, inside inside class A, method A is there. Inside class B, method B is there. Along with that, method A is also there. How? Because inheritance relationship is there. We are inheriting A. It means whatever feature is there in A, all feature is there in B. It means class B has method A and method B. And if we examine C, then class C has method C, method B and method A, because class B is extending, class C is extending B. It means B has two method, method A and method B, and C has some extra method, that is method C. Inside class D, method A, method B, method C, and method D. 4 methods are there. Inside E, method A, method B, method C, method D, and method E. That methods are there. So from this one we understood what exactly the inheritance is there. And okay, so now I will inheritance of, okay, wait, that is not that one. Yeah, reference typecasting. Okay, this is a main, this is our main class. So here what I did, I created one D object, and the reference variable also of a D type. Okay, and this is implicit typecasting. What is implicit? Because D is a type of A also, because whatever feature is there in D or whatever feature is there in A, all feature D has. So you can do typecasting, that is implicit typecasting, no issue. And from this A, okay, first I will get it here. Okay. Okay, so first I am just creating object D object I am creating, and the reference I am assigning into reference variable of a D type only inside D variable. Okay, and I am printing because D has all method. We have seen now D has which method? Method A, method B, method C, and method D is there. Inside class inside class D, method A, method B, method C, method D are there. Okay, so that we are printing, we are executing that method, that is no harm. Okay, just simple. After that one I am making a typecasting. I am typecasting to A, upper level, upcasting for to do upcasting. You that will be implicit casting. You don't need to do anything. You don't need to even if you type this one, that is no harm, but you don't need to do, because this is implicit typecasting. You can do because that is upcasting you are doing. And inside this method, inside this class A, only method A is there, so you can execute that only. You cannot execute any other method, like, because if you say I want to execute method B will not be there inside A. It will not there. Yeah, it's not there, so that's why it is giving error. See, compilation is giving error. What error? Method B is undefined. Yeah, it's not there, so I'm just removing this statement. And I am typecasting to C. Yeah, that also you can do, because D you can typecast to C also, because D is the subtype of C, same as D is the subtype of A, so you can do typecasting. And this is also fine. If you don't give this one, that is also fine. See, that is also fine. Explicit typecasting only. This is explicit typecasting only. This is explicit, implicit only, because D is the subtype of C only, so you can do, that is also implicit typecasting. This is implicit typecasting. And inside C, method A, B, and C are there, but D is not there. So you are getting exception here. And D itself is there, A, B. Okay, so if I want to typecast B, then how can I do B is equals to A? Can you do that one? You cannot do. Why? Because inside reference variable A, object of type what? Object of type D is there. So you have to do explicit typecasting, then only it will work. So this is explicit typecasting. And inside object A, object B, method A and method B are there. Yeah, these are there, but method C is not there, because inside B method C is not there. So it will give error. Okay, so this is explicit typecasting. I'm just removing. Okay, no need to remove. So this is explicit typecasting. Suppose Can I do the typecasting like that? Suppose object D, okay, object D is already there, object D is already there. Can we do that one? Yeah, we can do that one. So okay, first I will run this one and I will show you the output, then we will do that because it is exception case. Okay, so for D we are calling method A, method B, method C and method D. Yeah, method A, method B, method C, method T. Yeah, this is method A, method B, method C and method D of class A, class B, class C, class D, because method A is from class A, method B is class from class B, method C is from class C, method D is from class D. After that one I am typecasting, it's implicit typecasting to A, so we are calling A, method A, yeah, only method A. Again we are typecasting to C, so from C A B C, so 2 times A and A B C, same, it's calling A B C. And then we are typecasting to B, so we are calling method A and method B. After that one, suppose from D we typecasted to A, yeah, from D we typecasted to B, and from from D we typecasted to A, from D we typecasted to C, from D we typecasted to B. But from D, if we try to typecast to E, then what will happen? We cannot do at all. Why? Because whatever the reference, whatever the object that is holded by D reference variable is not a type of E, that is a type of D only, because E is inheriting D. So whatever feature is there in E, D don't know. So you cannot do the typecasting. So it will give class cast exception. Class cast exception. Java.lang. class cast exception. That exception is present into lang package. We will see that lang package. That is okay. That is different. So now, so this is I'm commenting this one. This is implicit typecasting and explicit typecasting for reference variable, reference variable. Suppose here we are getting one class cast exception. How we will know whether we can do typecasting or not? How we will know? So, suppose that is the chances. No, from here we are understanding, from here we are understanding this is a type of D, but this object is created somewhere else and some method is returning that object, and you will not able to see that implementation because that is compiled file or something like that. Then how will you identify whether we can do typecasting or not? To know to know that one, whether this reference variable is holding the object of particular type or not, we use instance of operator. Yeah, that is the use of instance of operator here. What is the use of instance of operator? Suppose we want to know what object is holded inside D, so we can do type check first. We can do type check. We want to check whether this D reference variable has the object of a particular type or not. To check that one, we use instance of operator. So what is instance of operator? Instance of operator is used to check the object for particular type. Instance of operator can only be used if the inheritance relationship is there between the type. If inheritance relationship is not there, then your compiler will give error itself. But if inheritance relationship is there, then you are not sure whether this object is that type of only or not. In that case, you need to use instance of operator only. If the inheritance relationship is not there between the object and type, then compiler will give error at compilation time. We will see this also through the code. Syntax to use the instance of operator is this one. Here you have to give the reference type of variable then we have to use instance of operator, and then we have to tell the types, which type you want to check. I want to check this reference of this type or not. This reference object has the reference of this type or not. So it will return a boolean value. Return true if the object reference variable is same as given type. True. So means the return type of this statement is boolean. Okay, so let's see that implementation. Yeah, instance of main. Suppose so here I have created one object of D, and the reference variable I am using of A type. Inside A, see, inside the reference variable A, inside the reference variable of type A, I am storing the object of D. Yeah, you can store, because this is a subtype only. You can store, no issue, you can store. Okay, so we are storing and we are calling the method of A. So it will call the method of A method of class A. That's it. Later on, I wanted to check whether this A is the instance of B or not. Means, what is the meaning of this statement? Whether the reference variable of A, A is it has the object of B or not. Obviously it has, because inside the reference variable A, the object type is D, and D is the subtype of B only. So definitely B object is there. So it will, you can typecast, no issue. So it will do the typecasting here, and it will execute this one. Here we are checking whether the reference variable A has the object of C. Yeah, it is there, because D is the subtype of C, because C has the subtype D. In that case, yeah, you can say that object A has the reference variable A has type C object also. So this is fine. So it will print method C from class C. Okay. Do here in this statement, do a reference variable A has the object of D? Yeah, obviously. Here from this statement only we can say inside reference variable A, object is a D, and that only we are checking. Inside the reference variable A, object of D is there or not? Yeah, that is there. Inside the reference variable A, object of type E is there? No, because inside object A, the reference inside reference variable A, the object is there. Object is type of D only. Reference variable A is holding the object of type D only, not E. We have not created any object of E, but in that case this will return false. So this statement will not executed. So class cast exception will not be thrown, and this till that it will execute. Yeah, method A class A, method B class B, method C class C, method D class D, method D class D. That's it. This will not execute this one, because this condition will be fail. See, method A class A, method B class B, method C class C, method D class D, but method E class E is not there, because object reference variable A has not the object of E. So that's why it is false. So this is that one. And see, you cannot do that at all. You can do this one. E, type of E, yeah, you can do this one, that's fine. You can do B, fine. You can do C, fine. D, E, yeah, that also you can do. A, you can do. Suppose what it will, I will print this one. Sorry. If I print this flag one by one, flag, what will be the value of flag? True. Yeah, it will be true. See, true. What will be the value of flag now? It will be true only. What will be the value of flag? now it will be true. What will be the value of flag now? Yeah, it is a type of C also, true. What will be the value of flag now? Because object A, sorry, reference variable A has object of D. Yeah, it is a true. It means it is also true. But reference variable A don't have a type of E, don't have the object of type of E. In that case, it will give false. So this is the use of instance of operator. But see, if I will say object A, reference variable A is the type of string. You cannot do at all, man. You cannot do. Why? Because there is no inheritance relationship between string and A, between string and class A, or there is no inheritance relation between this one also, student also. You cannot give that also. Why? Because yeah, this is student, but you cannot give that also. What is this one? Incompatible conditional operand type A and student. Type A and student, because between type A and a type student there is no inheritance relationship. You cannot do that one. And you cannot give the string also. You cannot give the string also, because it is the same thing, operand A and string. Incompatible conditional operand type A and string, because there is no inheritance relationship between type A and type string. Okay, so you can give this one, no issue. A, B, C, D, E you can give. Okay, so this is all about typecasting in Java. So in next session we will see this and super keyword. These are the keyword that is very useful in inheritance relationship and inside the class itself also, to differentiate the variable naming convention, something like that. We will see in the next session. So I hope you like this session. Please subscribe my channel, and if you have any doubt you can ask me in comment section and we will take out that also. So please subscribe my channel, and thanks for watching, and we will see you in the next session. Till that, bye bye.